This short video will familiarize you with the USGS earthquake website. So your lab assignment this week is going to be visiting this URL here and answering these series of questions. So the USGS is an important organization for you to know about. They're basically like NASA for geology. So they do everything, predicting earthquakes, magma movement, volcanic eruptions, landslides, tracking the evolution of the tectonic plates, all that kind of thing is taken care of by USGS. So let's click this link here. All right, so now we have pulled up a map of the world. So you can zoom out here with the minus sign or zoom in with the plus. And notice there are these red lines here. So these red lines are the plate boundaries, and the dots indicate earthquakes that have occurred. So if I want to have a look over here, I can see all the earthquakes that are happening or have happened in live time. So the most recent one was in Nevada. So right now it's set to UTC time. Let's change this so we can come over to the settings tab here. So click settings. And now we can change things if we would like. So right now we can see we're looking at all earthquakes only in the past day, magnitude greater than 2.5 in the United States. So we can also switch that up if we're interested in 7 days. Oh wow, there was a lot of earthquakes. Okay, so continue. So now we can see how densely populated that is. But your homework assignment is only looking at this one here. Okay, so now we can also change the map here. So we have map layers. And we also have plate boundaries is already clicked for us, but let's go ahead and click US faults so that we can see our fault maps here. So now if we zoom back in, we can see all of these red faults are now being shown. So when looking at earthquakes, we can see there was an earthquake here in Nevada very shortly, very recent. And we can speculate that it was caused by this fault range, right? So we could zoom in and get a better look of this here. Okay? So it's closest to this area, the Toyabe Range Fault Zone. So if we want, we can click terrain and we can get a better idea of things. So it just depends on what's easiest for you to see. I prefer terrain mode. That really helps me visualize things. So I'm going to zoom out here. All right, so you can see some nearby cities here. Okay, so once these layers are flipped, you can also change the local system time. So right now we're looking at UTC. Maybe we want our local time here. So now we can come back and we can say, okay, so at 1:49 p.m. today, which was less than an hour ago, we had a magnitude 3.2 earthquake in Nevada. Pretty cool. And I don't know if you guys felt there was one yesterday here in Los Angeles, the 3.7. Maybe some of you guys felt it. I barely noticed it, but a lot of my friends had things fall off their shelves in the Hollywood Hills here. Okay, so if you want more information about the earthquake, you can also double click it. And it'll take you to this information here. So it tells you where it occurred, 1 kilometer south of View Park in Windsor Hills, California. So let's click on that. And now we can see all of the information that the geologists have published from this earthquake in California yesterday. So you can look at an interactive map, some of the regional information. You can report to USGS if you felt it, and they'll add your response to their survey. Right, so you can see they already have a community intensity map constructed. You can look at the shake map to see where the most shaking occurred. Right, so this is what USGS does. Right, this is their job basically, is to Record, catalog, and detail these earthquakes. Describe how they formed. Send out reports to citizens, whether it's social media or other reports to get their shake response, all those types of things. So your homework or your lab assignment will be to answer a series of questions about these earthquakes using this lifetime USGS chart here. So how many occurred in California over the last day? And you'll also be asked some questions on how the earthquakes formed. So use what you know about plate tectonics. Look and see if the earthquake occurred near a plate boundary. And if it did, then it was probably caused by that plate boundary, whether it's subduction or whether that was from divergence or seafloor spreading. So you can use your knowledge of plate boundaries, and also you can use the internet and research the local regional tectonics of that particular area for each. And also you can use our lecture slides. So both the lecture on earthquakes and the lecture on the geology of California will come in handy. On the last question, it looks at a recent earthquake in Idaho. So this was a 6.5. So read this summary here. No, I don't want to do that right now. So read this summary here, and then I ask you, what caused this? If we go and we look over at Idaho, let's put our fault map back on. And then we can zoom in here to Idaho. Okay, so here's Idaho. We can see it has a cluster of earthquakes. It wasn't just the one that occurred. So there was a bunch of different earthquakes all happening in this region here. So from your knowledge of this area, right, you've got this faulting network here that is, significantly displaced from the plate boundary. So we know all this faulting here in SoCal is because of the San Andreas. But remember, out in Nevada, Idaho, this Four Corners region is the region of extension. Right? Remember, the crust here is being pulled apart. Nevada has been stretched. The crust of Nevada has been stretched by over 100% because it's likely rifting that's happening here. So the crust is being torn apart from the subduction of that ancient spreading ridge. So this is the Basin and Range province here. Right, so you can see Great Basin. So visit those slides, week 5 slides, or the lecture from the Geology of California on YouTube, where I talk about the Basin and Range, and that will help you answer that question about what's going on in Idaho. Okay, good luck with your lab. I'll see you guys soon for your lecture.